Problem 85, Quantum Mechanics. The question is, the product of the uncertainties delta Lx delta Ly for a particle in the state A 1 1 plus B 1 minus 1, where Lm denote an eigenstate of L square and Lz, will be minimum 4. Here we have to find out the value of A and B, for which the product of the uncertainties delta Lx delta Ly is minimum. Here the state is A 1 1 plus B 1 minus 1. Here 4 options are given. We have to choose the right option. First, let us write the expectation value of Lx, that is psi Lx psi, that is A star bra 1 1 plus B star bra 1 minus 1. Then what is Lx? Lx is actually L plus plus L minus by 2. Then get psi, that is A 1 1 plus B 1 minus 1. This is equal to 1 by 2 times A star 1 1 plus B star 1 minus 1. Then the first term is L plus acting on A 1 1, that is root 2 h bar B 1 0 plus root 2 h bar A 1 0. And when you take the inner product, the value will become 0. Similarly, you have the expectation value of Ly is also equal to 0. Now let us find out what is the expectation value of Lx square and Ly square. The expectation value of Lx square is equal to A star bra 1 1 plus B star bra 1 minus 1. Then what is Lx square? Lx square is nothing but L plus square plus L minus square plus L plus L minus plus L minus L plus. Then get psi. Here there is a 1 by 4 outside plus A 1 1 plus B 1 minus 1. This is the expression for Lx square. Now we have to find out each term separately, that is what happens when L plus square operates on A 1 1 plus B 1 minus 1, etc. We have total 4 terms inside the bracket. So we have to evaluate each term separately. First, let us find out what is L plus square acting on A 1 1 plus B 1 minus 1. This is nothing but L plus acting on L plus A 1 1 plus B 1 minus 1, and that is equal to L plus acting on A into 0 plus B root 2 h bar 1 0, that is equal to B root 2 h bar B root 2 h bar L plus 1 0, that is equal to 2B h bar square 1 1. In the same way, let us find out what is L minus square acting on A 1 1 plus B 1 minus 1. This is equal to L minus acting on L minus A 1 1 plus B 1 minus 1. Let us close the bracket. This is equal to L minus acting on root 2 h bar A 1 0 plus 0, that is equal to root 2 h bar A L minus 1 0 root 2 h bar A L minus 1 0, that is equal to 2a h bar square 1 minus 1. Next, let us find out what is L plus L minus acting on A11 plus B1 minus 1. That is L plus operating on root 2a h bar 1 0 plus 0. That is equal to root 2a h bar L plus operating on 1 0. That is equal to 2a h bar square 1 1. And finally, what is L minus L plus operating on A11 plus B1 minus 1? This is equal to L minus acting on L plus A11 plus B1 minus 1. That is equal to root 2b h bar L minus acting on 1 0. That is equal to 2b h bar square 1 minus 1. Now we have evaluated the 4 terms. Now let us find out what is the expectation value of Lx square. This is equal to 1 by 4 times Lx square, that is equal to 1 by 4 times within bracket a star 1 1 plus b star 1 minus 1. Then let us substitute the values of various terms we have determined. That is 2b h bar square 1 1 plus 2a h bar square 1 minus 1 plus 2a h bar square 1 1 plus the last term is 2b h bar square 1 minus 1. That is equal to h bar square by 2 a star b plus ab star plus modulus of a square plus b square. This is the value of the expectation value of Lx square. In the same way, let us find out the expectation value of Ly square. This is nothing but h bar square by 2 within bracket modulus of a square plus modulus of b square minus a star b minus b star a. Now let us find out what is delta Lx and delta Ly. We have the expectation value of Lx equal to 0. Therefore, delta Lx is nothing but the expectation value of Lx square. We have evaluated the expectation value of Lx square. Therefore, delta Lx is equal to h bar by root 2 square root of modulus of a square plus modulus of b square plus a star b plus b star a. This is the value of the expectation value of delta Lx. Here, remember that modulus of a square plus modulus of b square is equal to 1 because psi is normalized. Therefore, we can write delta Lx as h bar by 2. The first two terms, the sum of the first two term is 1. Then 1 plus it is 1 plus a star b this is the root of 1 plus a star b plus b star a. Similarly, we can find out delta Ly, that is equal to h bar by root 2 into root of 1 minus within bracket a star b plus b star a. Now what is delta Lx, delta Ly? This is equal to h bar square by 2 then square root of 1 minus a star b plus b star a multiplied by 1 plus a star b plus b star a. Now we can write the product of the uncertainties delta Lx delta Ly as h bar square by 2, then 1 minus a star b plus b star a whole square. This is the value of delta Lx delta Ly. Now let us find out the correct option. For that purpose, let us choose or let us consider option D. Suppose a is equal to plus b. Here, when a is equal to plus b means a is equal to 1 by root 2 and b is also equal to 1 by root 2. When this condition is satisfied, delta Lx delta Ly becomes 0. In all other option, if we check, it is greater than 0. Therefore, we can say that the minimum value of delta Lx delta Ly equal to 0 corresponding to option D.